let's take a look at an eBay or indeed AliExpress skeleton shaver. I don't know why I ended up buying this. I think it just popped up with some other listings and I thought that is super stylish. I like the fact that it's all exposed for easy cleaning and maintenance. Now, one of the problems with razors that I normally have, this one is rechargeable instantly, USB-C with a little button to turn it on and off. One of the problems I normally have with them is that I've got very, very fine hair because sometimes I shave my head. And that's the ultimate test. So I'm about to just take the beanie off and let's shave my head. So I'll bring it in here. Not bad. Not bad. Okay, yeah, that is working. That's pretty good. So I'll get the rest of that later on. Otherwise, I'm going to look extremely odd. So I'll put the beanie out of the way now. It's going to end up covered in hair. So far, so good. I want to point out I did put some oil in this before using it because that is what you're supposed to do with shavers. Now, how does this come apart? I see it's got springs here. Let's lift the springs. And does this lift off at that? It should lift off. Well, it does pop off like that. It's good for access. I'm going to take these screws out now. Where's a suitable driver? Here's a suitable driver. Maybe that's not a suitable driver. Let's not chew the screws up. I'm hoping they've not glued everything into the interior of this because it's going to make it very hard to get out. If I'm very lucky, they'll have used a technique with a sledge, a plastic sledge that goes through and is being held in by these two screws. But it is the moment of truth if that is the case or not, because otherwise it's going to be very hard to get this out possibly. Hopefully this will release everything. We shall find out in due course. And I chose this one instantly because it's got a picture of the guy with the big beard. It's quite stylish. Is this going to push out? Is this going to push out? Oh, it's not. It is not necessarily going to push out. I can see it's got a sort of split case that looks as though it is kind of designed to grip in with friction. Have I got anything I can slide over this? I shall just take a hunt for something and see if I can find something. One moment, please. Uh-oh, this isn't going to plan. I shall use some heat in this and some, perhaps drizzle some solvent down. I'm not sure. I'm guessing there's an 18650 or something in here. I'm going to have to proceed with caution here. I don't want to damage the battery. But I shall pause while I do this because I'm not sure how long it's going to take. And then I'll get into the reverse engineering. One moment, please. And resume. Let's zoom down a little bit. So the first thing I actually did with this before opening it was I rebuilt it and shaved the rest of my head since it was doing such a good job. It did a very good job. It stalled a couple of times when being shoved into the hair too hard, but other than that, it was perfectly fine. However, getting it open turned to be quite difficult. I thought that this was going to be a plastic carrier all the way through, and that by releasing the screws, as you saw earlier, that the whole lot was going to slide out. That did not happen. It turns out the motor is actually in a plastic housing, and it's kind of, the plastic housing is a little split in it here, a deliberate little slot. And in the process of manufacturing, they basically ram the motor hard into it and it wedges it out against the side of the case. Very hard to remove without using a hammer and probably wouldn't go in very well again afterwards, so I left it. I initially, in my process of discovering that, decided to heat the whole thing up after solvent, isopropyl alcohol, and a bit of locally applied heat did not do much. So I put it in the air fryer at low temperature. It turned out to be slightly higher temperature. It came out very hot to the point I was thinking, well, this contains a lithium cell. This is not good. It didn't help anyway. What did help was just being reckless. You can see the slight scuff marks here, and pulling the bottom cap off, and that revealed this circuit board is loose in, well, it's actually screwed into this cap, and then there is an 18650 stuffed up there with a capacity of approximately 1 amp hour, as you might expect. And it's notable that they've soldered directly onto the ends of both ends of the lithium cell, which is a bit naughty. The lithium cell also has a sticky pad for insulation in each end, which is okay-ish, I guess, as long as it doesn't get rammed down too hard, because there are the motor connections sticking out the back down there. let's go to the circuit board, which is this, which is surprising. It's not what I was expecting. It's a bit kind of, yeah, it's a bit silence-inducing. It's not got charge circuitry as such. It is very odd. It is based around a little microcontroller, which you'd expect. It has a diode and a capacitor across the motor, and the motor is switched by an A2SHB MOSFET, which has a 10k pull-down resistor on its gate and a 100 ohm going to the processor to actually turn it on. There is a decoupling capacitor, and that's all that's on this side of the circuit board. This side is flipped to make everything sort of correlate. So that's one side of the circuit board. I'm not sure why they well, I'll show you another side. It's kind of strange. Things worthy of note, they've just bonded the identification pins of the USB-C connector together. No resistors, plenty of room for them, but they didn't put resistors in to signal, that it was a charging device. This is the other side, flipped, which is why everything is in reverse. It's got a 100 ohm resistor, a J3Y transistor, and a red and a green LED, the USB-C connector, and it's got the clicky button, and then the strange link. It doesn't need that. It's because it only really needs one connection, but that's strange how they did that, because they are kind of tied across anyway. These two are tied across, and they kind of screen printed there, and they've just put, I've got the pad sitting on the screen print. It's a bit of a strange circuit. Let me show you the schematic, and those of you who have a nervous disposition might be concerned at the charging circuitry. The charging circuitry is this transistor which switches the 5 volt down to the positive rail, the lithium cell. There is no specific current limiting. I think they're relying on the transistor for that. It gets warmish. It got up to about 30-40 degrees Celsius. And that is turned on by a 100 ohm resistor from the 5 volt supply, which then relies on the processor actually booting to be able to actually control the charge. It's very strange. Not sure what they were thinking of here, but let's come back to that in a moment. The lithium cell is here. It's got a decoupling capacitor. It's got the microcontroller. The microcontroller has current limited outputs. It has a button going to the 0 volt rail. That's the clicky button that turns it on. And it's got the two LEDs, red and green. It's notable that this pin is very capable. It's actually monitoring. It knows when there's a USB supply is connected, because it's abusing it big time. It's just a bit weird. The MOSFET is here. It's got its 10k pull-down resistor for stability. It's A2SHB, A2SHB, which is everybody's favourite tiny little high current MOSFET. 100 ohm resistor to the gate from the processor, and that switches the motor, which has a little tiny decoupling capacitor across it for noise reasons and anti-glitching of the transistor. That's that little capacitor there, plus this diode, which is also across the motor to absorb to basically shunt the back EMF spike when it's disconnected and the magnetic field collapses. Getting back to the charging circuitry. So, very oddly, I connected another battery to it that was in a low state of charge, 3.15 volts, and it charged at 150 milliamps. The only thing that's really limiting the current is this transistor here. Not sure what's going on here. It charged it up to 4 volts. At 4 volts, the red LED lit to show it was charged, but the red LED lit to show it was charging. At 4 volts, it stopped charging the lithium cell, but it still kept the red LED powered, and the current from the lithium cell actually showed current flowing to feed the circuitry, so minus 8 milliamps was at that point, which was basically just powering the red LED. Then it dropped slowly back to 3.97 volts, then it changed to green, and at that point it dropped to minus 4.3 milliamps, but that's only when the LEDs are lit, because it can detect that it is connected to the 5 volt supply via this line. They've been cheating big time to get this. Even when it had fully completed charging, the circuitry was passing 38 milliamps on the USB supply, because effectively, to turn the transistor off, it only has to pull it roughly a wee bit below this rail here. Even pulling it to this rail would turn it off, because the base of that transistor, which is an NPN transistor, has to be 0.6 volts above that rail. So it pulls it to the 0 volt rail, and that effectively turns it off. But there's a fair amount of current flowing through that resistor and through the processor and to the 0 volt rail. And it's not a decisive, it doesn't pull it down to 0 volts. It's just basically biasing it so it's somewhere between the plus rail and the minus rail. So the processor was actually getting warm at that point. Very strange. Other things worth mentioning about that. Yeah, theoretically, there's going to be a diode, a anti-static protection diode there, which would compete with the diode in the transistor. So it's very much just delicately balanced. That might be why the transistor didn't turn on fully and acted as a current limiter during the charging. It's very strange. Peculiar circuitry. It works. It stops the charging at 4 volts. So the actual lithium cell is theoretically going to last a good length of time because it's not being charged to the full 4.2 volts. It still has plenty of shaving power, even it's at a half charge. I presume there's a lower limit that the microcontroller will just shut the MOSFET off as well to show that it detect that the battery is low. Either that, or you'll probably hear the shaver getting low speed and it will start stalling quite a lot when you touch it to its stubbly hair. But that is it. It's very peculiar. It's the weirdest charging circuitry I've seen in a long time. And I've seen some weird charging circuitry. So these things are quite stylish. There are a few oddities, squirmy bits, just the usual squirmy bits you'd expect from Chinesey type products. It is mass produced to the hilt. The price varies dramatically. Some people are selling this as a designer accessory. I don't know if there's a designer brand that is expensive and then a cheap knockoff, or if it's just people price gouging it. I think people are drop shipping these from China on eBay, from AliExpress. But it's quite stylish. Also, the logo, the popularity of the logo determines the price. This one has the bearded guy with the sunglasses and the cutthroat razors and a crisscross skull and crossbones style. This one was more expensive because obviously it's more popular for that image than the others, because it's a trendy sort of tattoo industry, barber industry type sort of designer steampunk accessory. But that is it. I will put this back together now, being careful about the placement of this lithium cell with its little sticky pad. And I'll probably use it because it did an extremely good job of trimming the hair. It's not bad at all in that regard. So it's weird, but it works. It doesn't really ridiculously overcharge the cell in any way, but it's just got weird circuitry. But to be fair, it does work, and it's a decent shaver. It's the eBay AliExpress skeleton shaver.